Okay, we are now recording. Welcome to the first Python tutorial of the summer 22 season. In the summer, we'll meet every other Thursday or thereabouts at 1 p.m. Mountain Daylight Time. And we'll cover various Python topics and build our toolkit and skills as you can use Python for your complete scientific workflow. But first, while I give a little rundown on what Python is and while we're using it, please make sure you've installed the requirements for this course. So you need to have Conda and Git installed. So open up a terminal. I will be using a bash terminal, but you can use whatever you're comfortable with. Again, this tutorial is geared towards scientists who have some computational experience but are new to Python. So you should know how to use a terminal and a text editor, and you need to have Conda and Git. Check that you've installed them by typing conda -- version. If this has failed, that's because you don't have Conda installed. Same thing for Git. And if your Conda version is older than 4.8, please update it. I can post, let me post this link in the chat for you. It's also in the Google event. So let me go grab those. Here in the chat is Conda installation. And Git installation. And now I have maybe nagged you a little bit about doing this. And if you have not, hopefully your internet connection is fast enough that you can get that done in time. Okay, so while everyone is figuring that out, and if you need help, hopefully one of the co-hosts can help you. I'm going to give a little rundown. So a little bit about myself. My name is Julia. I've been with NCAR for 3 years and have dedicated a lot of work to helping improve the efficiency and reproducibility of open science, specifically for climate and other geoscientists, by helping develop tools for geoscience workflows, working directly with scientists, and to help get these workflows running or more modernized, I guess, and through some educational efforts, including Project Pythia and this tutorial series, so that you guys can know what the tools are and how to use them. So before we begin, I'll remind everyone that by attending this tutorial, you're subject to the NCAR-UCAR Code of Conduct, and any inappropriate comments, we will remove you from the session. You can still watch the recording afterwards, but please remember that we're all trying to help bring these learning resources to you. Okay, so this first series, as we bring the tutorials back, will span 3 sessions covering building a Python script, working up to calculating wind chill index. So today we're going to read in a text file, set up our environment, our workspace, grab the data, and just kind of get our feet wet with some basic Python and Git commands and data types. So we're mostly laying the groundwork for what's to come. So by the 3rd session, you should have your first full script, and then we'll move on to repackaging that so you can call scripts in from other Python files and just a cleaner, more complicated analysis. This is a repeat of the tutorial I gave almost 2 years ago, and I've made some edits based on the most common questions that came up, but generally it's the same content. So if you attended then, welcome back, and hopefully together we can go to a deeper level of understanding. And if this is your first time around, welcome and good luck. So again, the target audience is scientists who have some programming experience, perhaps in a different language other than Python. So you might be familiar with for loops and things like that already. So we don't have to really explain that, but we have to focus on the syntax and why it is the way it is. So if you've already done NCL, IDL, MATLAB, some popular ones, this is also a high-level interpreted language. High-level means that a lot of commonly used functions and data structures have been provided for you, and you don't have to worry about things such as memory, use and allocation, and performance-related information, which most scientists are not. You don't necessarily have the capacity to think about that on top of your workflow, on top of your scientific discipline already. So this simplifies things for you. Interpreted also simplifies things for you. Your code is portable, it's compatible across machines, it's easier for you. It also might be a little bit slower and a little bit less performant. So if you were a Fortran master, you could probably get your code running faster, but this will be a lot faster to learn and ultimately less time spent working on your code. And one of the things that I love about Python is that it's open source. So this means that other scientists elsewhere who might be solving similar problems to you can make their code available, and you can use it in your workflow without having to buy anything extra. And so it really is kind of embodies what we're trying to encourage, which is the sharing of scientific workflows so that each of you can spend less time banging your head against the keyboard and more time doing the actual science that you're trying to get done. So that's why Python uses a lot of packages, and that can be confusing at first, but that's why we're going to try to introduce it slowly. Focus without any packages for these first 5 sessions. You will build a package, a very simple one to kind of demystify what's going on. And then we will introduce some of the more popular scientific packages. Okay. Also, I've heard your requests, and I will be working on a little lesson, a blog post, a tutorial, a forum. Not sure how much content there is for the perfect format for it, but on the best practices for package management. So I will try to get that information to you. Today, we will learn pure Python, some Conda, and best practices for saving and organizing your work. Because each session is only an hour, I will try to run through everything as detailed as possible, and I'll stop for some questions. But you can also ask them in the chat at any point, and some other team members or each other can try to help out. And there'll be a 2-week break before we move on to building a Python data dictionary. So we should be able to get you up to speed between now and then. Okay, and I see that we have our first question. Can I run the Conda used in this tutorial in RStudio with the Python file? About that, I haven't used RStudio, but I'm sure if RStudio has a terminal available to you, everything I'll be doing, if you want to mirror exactly what I'm doing, you will need a terminal with a text editor. If you are comfortable using a different Python interface, such as Spider, you can do that as well. And yes, this will be recorded, and I will send it out to you once it's viewable. Okay, editor for Git on Windows. Any Windows users want to, let me even look up what the Git editor options are. I'm not sure if it will matter that much. I think I used Notepad++ too when I used Windows before converting to the Apple ecosystem. As long as you know how to open a file, close and save a file in whichever editor you choose, you'll be good. You'll be golden. Of course, there's some other like keyboard highlights you might be more familiar with and some than others. So it's really up to you. Okay, and here's some links for today's content. As always, you can go to Stack Overflow for some questions. And let's see. Here is a link to a website that has all of the content on it that you can follow along. And Project Pythia is a great resource that me and some other people on this call, or myself, we've been working really hard to get this in a state we can bring to you. And it has a lot of great foundational chapters on anything Python related you might want to learn. Yes, Visual Studio Code. Thanks, Max. I use Visual Studio Code in my day-to-day work. So again, any editor you want to use is great. Okay, let me just transition from these slides to the terminal. Okay, can everyone see this okay? Okay, so I will demonstrate, again, checking our Conda environment, or Conda version. So if you still haven't done this, it's Conda -- version. I'm at 4.12. If you are below 8, do Conda update -n base Conda. And I am not going to run that because I am already up to date and we don't need to deal with that. And similarly, check your Git version. Okay, so in figuring out our workplace, where are we? I'm going to move into a documents directory, and then I'm going to create a new folder for this tutorial. And of course, you can put this anywhere you want, as long as you remember for the next couple tutorials. So I'm going to make a directory with make directory, and then Python tutorial 22 for 2022. And I'm going to move into this directory. And now from here, I am going to create a Conda environment associated with the package that has Python in it. And this, I'm going to give it the same name, just to know that they're associated. It's a good idea to have a different environment for every one of your projects. That way you don't have to worry about updating your code in one place to use a new feature that was released, and that changing something in a different workflow that you want to make sure is exactly the same as it was at the time your paper was published or something like that. So you want to make sure you know exactly what environment is what. So go ahead and create your Conda environment -- name, then the name you want. And then after that, I'm going to type Python. So every argument after your chosen name is going to be something that is going to be installed into this environment right now. Of course, you can do Conda install whatever package once your environment is activated and deal with that later. But since we're just installing Python, we're going to do in one line installing Python. And we'll just wait a second for this to happen, for this to work. Okay, and then you'll get this option if you want to proceed. Go ahead and say yes. Okay, great. Mine is now ready. You can comment in the chat if you need me to wait a little bit longer, or if you need to see the command again. Again, the command is on the site, but I'll just type it in the chat real quick for you. Okay, and once you have your environment, go ahead and activate it with Conda activate, and then the name you chose. And you can see that this is activated because I now have these little parentheses in my terminal that tells me where I'm at. If that did not work for you, I know some Windows users try activate Python tutorial without the Conda in front. Okay. Okay, we have to set up Git, and then we have to download our data, and we'll have our workspace pretty set up. So to download or to get Git initialized, I mean not downloaded, git init dot. Okay, I've initialized an empty Git repository. Okay, some things, if this did not work for you, you can try git init without the dot pointing to your directory. This might happen on Windows. So you have to go inside your project folder and right click to choose where you want your Git possibly. And some of you might get a message along the lines of, please tell me who you are. If this is, if this is the first time you're using Git on your computer, you might be seeing this. So that's because when you make changes to your repository, Git is collaborative, and so it wants to track not only what those changes are, but who made them. So you need to create an identity associated with Git. So if you saw that message, please tell me who you are. It's gonna below it tell you exactly what you need to type. But those two commands will be git config -- global user.email, and then in here you put your email address in these quotes, and then again git config and then user.name and then your name. Let me just post those in the chat real quick. There's the two options if Git is giving you a little reading. Okay, does anyone have any questions so far? Are we ready to download the data? How do you check your name if they're already set? That is a good question. Let me see. Let me see if I can figure that out. So Git config dash get and then, well, that'll take my name. So if I want to figure out what it is, I think I'm gonna try git config dash list. Okay, I will do it with 2 dashes. Okay, yep, so that's how you do it. My name is Julia. Here's my email, all of that. So I will type that again in the chat for you if you just want to copy and paste it. Okay, that was a good question. Yes. Okay, so what is a Git repository? It's a folder inside of your project that adds version controls to your directory and all of its contents, which is currently nothing. But we're going to change that and add some data in just a second. I sometimes like to think of Git as like a very advanced version of like a Google collaborative editing where you can look at your version history, you can track your changes, and you can go back. Git is similar to that, but it's optimized for working with software, working with code, working with version releases, things like that. It's the tool you want to be using. So first, let's make a data directory. And then let's go into it. First, we can check that we have it here. Okay. Go into data. And the file we're going to use is from the Davis Instruments Wireless Vantage Pro 2, located at CU Boulder East Campus on the Seek building. The station's monitored by their Atmospheric and Oceanic Sciences Department, and it's a part of the University of Colorado Weather Network. So there's a few ways to download a file from a website. Let me just post the website in the chat here. And one way to do this, I'm going to do curl-k, capital O. Sorry, let me just make sure that's not a 0. Okay, that's an O. And then the website. So you can paste it. It is https://sundowner.colorado.edu/weather/ATOC8 and then WXOBS 2017-08-21.txt, which some of you might remember as the day of the eclipse. So there might be some interesting patterns in the data here. Okay, that's a lowercase k and a capital O in this curl command. And I now have it downloaded. So if this does not work for you, you can try curl and then the link without the KO, like this. You can also try to use wget if curl is not working for you. So I think this might be the case for some Windows users, maybe. Do wget no check certificate, and then the link. Another thing that sometimes happens here is, let me see, sometimes on Windows, it wants you to specify where you're downloading the data to. So like if I show you, so it automatically just picked like that end of the name to be the file name, but you can also do curl, the link, and then dash out file, and then the name that you're after. Like that. see. I think. Okay, good. That's good to know that without the KO worked for you, Sarah. Okay, does anyone else need us to wait here? Okay, so Nachiketa, you're not just gonna post the link in your terminal, you're gonna post either curl and then the link or wget and the link to grab it. Let's see what happens if I just post the link. Nothing's happening for me. So are you, what machine are you on? Oh, okay, you did the curl. Can you do an ls in your terminal to make sure that it didn't download the data and just display it all also? You tried with the KO, without the KO, all of these combinations, and it's not showing anything. Is this the case for anybody else? Okay, same thing happened. Okay, thanks, Bill. So your solution was adding your wxobs.txt to the end as like the file's new name. Am I understanding that correct? And is that something that you can try? Okay, great. I'm glad to know it's working. Okay, oh, it's asking enter host password for user T file. This might be depending on the computer. Do you have permissions to download data to whatever computer you're working on? Let me see if I can look up your error right here, or your warning rather. Did you use the wget or the curl, Melissa? Curl, okay. Oh, you don't have ls, okay. Yeah, if you're on Windows, you can also just go to the file in your browser and download it from there and move it into your correct path. You can also try, as Mike points out, directory dir for where you want it to go. For ls being not recognized, let's see. Okay, yeah, use directory or dir instead of ls on Windows. Okay. Okay, yeah, Melissa, I'm not sure. We can work with you more, but you should be able to just grab the file in the meantime without doing it in the terminal so that we can keep moving together. Oh, great. Okay. Okay, everyone. So it seems like hopefully everyone who's spoken up has had their issues resolved. And if I missed you, please speak up again now. We're about to use Git and introduce our first Git commands. So the first thing you can do is Git Status. And this tells us that nothing has happened. So nothing has happened yet. There's been no commits. There's been an untracked file in a folder. This will not have worked for you if you never typed git init. So if you're seeing an error here, go again and type the git init command like so, or without the dot if you're on Windows. Okay, so this data directory is listed as the // because I think that because we're in there and it's untracked, which means all of the files in this directory are also not tracked by GitHub. So GitHub doesn't automatically care about everything in your folder. It will see everything and it'll point it out like so. But if you want Git to know what you've done, be able to go back to what you have done, you need to add it. So we do that with git add. And then the name of your new file. 170821.txt. Okay. So this has now staged your change, which means that you're moving a file that has been untracked or modified to the stage category. So it'll no longer appear down here. It'll appear up here where it says no commits yet. So to double check that this worked, do git status. Oh, yeah, sorry, still no commits, but now there's changes awaiting to be committed. Okay, can I briefly describe what a commit is? Okay. So a commit is kind of like it's a building block of using Git. So it can be thought of as like a stopping point in your work or a milestone, a snapshot, like a picture. Basically, it's a save version. If you haven't made a commit, you cannot go back to that version that you had. So every time you make a commit, you are taking the changes that you did and you are committing them to your workflow. So you are saying, I have done this, great, here it is. And then you're like, oh no, I shouldn't have done that. You can actually go back to before. And so best practice for commits is that you do one for every like compartmentalized change that you might have done in your code. It's almost like saying like every time you save a file, but with more intention than that. It's like more intentional than that. Okay, so there's some questions. Let me just kind of briefly look at these. Okay, yeah, so if it's asking you for the host password, try the curl-ko, the link to the data -o test.txt and make sure that works. Okay. Sarah, what's saying it did not match any files? Okay. Oh, it's saying like that file doesn't exist, or like, what is your call when you're getting this message? Fatal path spec does not match any file. This is after you did curl or wget, after you downloaded it. Can you confirm that you have the URL correct? Are you able to navigate to it in your browser? Okay. And so it didn't download. Okay, let's see. See what we can do here. YE fatal. Let me I'll search for it here on the desktop so you can kind of see my process, and maybe this can help you debug yourself in the future. Path spec did not match any files. Okay, so a lot of these are about Git. So I guess that makes me wonder, are you sure this isn't after you're doing is this when you're doing the Git add? Because I'm hearing that this is when you're doing the download, so that these aren't what you're looking for. It'd be helpful if you copied into the chat exactly what you wrote in your terminal. You should be able to see the file if you do an ls or a dr. If you're on Windows, that's not going to work for me, but within the data directory too. So you are using two systems. Okay. I don't know, maybe someone else on Windows can chime in and help you out, because I'm not very familiar with what you mean by that. Okay. Yes, there should now be a text file in your data folder. So if I move up one, there's my data folder. If I move into my data folder, there is your text file. Okay. Again, this tutorial is geared towards people who are already familiar with the terminal and how to use a text editor and things like that in the terminal. So I don't want to dedicate that much more time to specific terminal problems, because again, that was some of like the prerequisites for this course. But I hope that you can get the answers that you need and that I can meet with you maybe afterwards too to help figure it out. Okay, so after you've done your Git status and seen that you have a new change that has been added as a tracked file to GitHub, it is time to commit it, to do our first commit, our first save that we want Git to really be aware of. And this is going to be done with git commit -m. And then the message you want associated with this commit. This message is useful for you and ideally is going to describe what you did since your last commit. And this will make it easier if you ever want to go back in time or just kind of see the log of what your progress has looked like. So what we've done so far is we've added a sample data file. Okay, so we had a file changed. I guess it's a 578 line file, and it is now has now been committed, and we can see that with the Git status. Oh, it says I'm on branch master. Okay, wait. So we actually want to encourage you to change your Git name to be main instead, to use just better language. Okay, so you should be able to do that with a git branch -m master and then main. If yours already says you're on branch main, that is great. Okay, so that works. I'm now on main. It is more descriptive of what's actually going on and not, reminiscent of, master slave terminology that has been used in software before. Okay, and it'll say nothing to commit. And that's because everything that has happened has been committed. And there's also no files in our directory that we haven't committed. Okay, so I'll post in the chat that command again if anyone needs it. Okay, let me just do a clear so I can move up to the top of my terminal again. And I'm going to do a Git log. And here you will see every commit that you have done. There will be the time that it happened and the description of it, as well as this commit code or number commit, this, which is not very human readable. It's more like for the machine to understand. Okay, on Windows, sometimes we see this error where it says, warning, LF will be replaced by CRLF in your file. And don't worry, CR means carriage return and LF means line feed. And both are used to indicate line termination, like what's at the end of each line in your file. And most text editors will account for this difference between operating systems, but sometimes conversion is warning, which is necessary, which is why it's warning you, but it's probably not going to be necessary and you don't have to worry too much. Okay, has everyone been able to print their Git log? You can also do a Git log one line. And this just shows the first 7 characters from the Git commit and your message, and kind of simplifies out the time. It might be easier to read once you have a lot of them going on. Okay, after changing from master to main, does the sample file need to be re-added? It should not. I just did that and I did not have to re-add it, right? So if I do the git status, you'll see that it's not showing any untracked files. And it's still there, even though I changed the name of my GitHub branch or my Git branch. So again, that command was git branch -m for move. And we're just moving it, which sometimes means the same thing as just renaming it. Okay, so if you're getting an error that master's not found and branch rename failed, you probably did not need to rename it already. You're probably already on main. So if you do a git status and it says on branch main, you're good. Okay, so Asiya, you says, so you're on, okay, so you're both on master and it won't let you rename master. It has your new file there. So maybe I should just back up a little bit and see if we can go through this again together. So have you done the git add, and then your file. Okay, so you've done that, but it still says to be committed. Yep, okay, that makes sense. You can go ahead and try the commit and then we can try the name. So git commit -m and then your message like that. I'm not executing these, by the way. I'm just typing them out for you. Okay, so you're able to commit. And now when you do a git status, it looks kind of just like this, but it still says on branch master instead of main. Yes. Okay. So maybe now try the git renaming. But also this is not vital to it working. It's just a shift that GitHub made about 2 years ago now. So more and more projects are adopting it, and I wouldn't want to get you guys started off on the older version and why, there's reasons we don't want it anymore. Okay, that worked. Great. Okay, so now we are finally going to create our first Python script. I'm going to do a little clear here. Okay, so we're going to go up out of our data. Make sure you're in the top level of your folder, and you're going to create a new script. So there might be a few ways to do this. So I like to use just the touch command creates a new script, and I'm going to call it mysci.py. Some of you might get a message that this is not recognized as an internal or an external command. And if that is the case, something that has worked before is Conda install m2-base. And this will enable Unix commands in your Conda environment, in your Conda environment will now recognize Unix commands. And so does anyone need me to wait for them to install that? And we're about to use a text editor. Okay, I'll wait for you, Cassie. So I'm going to use Nano. Some people like to use Vim. If you're using Visual Studio Code, you can use whatever text editor you want, but use this time while we're waiting for everyone to install to make your decision. Okay, great. Cassie's done. Hopefully anyone else who's installing it, there's took a similar amount of time and we can move forward. Okay, what is M2 base? Good question. Here is the documentation for M2 base on Conda. Actually, that doesn't have any description. But basically, it is the Conda package that lets you use Unix commands in your Conda environment, and that's just the name of the package. So that should work for you. I can try to get more information on it. I have not had to use it on Mac, so I just kind of took this as a solution that other Windows users found and am spreading it to help you. Let's see. Yep, it is to help you get a decent Unix toolkit on Windows using Conda. I don't know if there's anything else more to say to that about it, but if anyone who knows more wants to chime in, you're welcome to. Okay, so let's go into the file. I'm going to do nano mysci.py. And voila, I am now in my text editor for the file. And sometimes moving around in here can be a little, it can be a little confusing. It can be disorienting. It definitely took some time to get used to a text editor that I have to kind of use quick links and things to move around instead of just being able to click. But it shouldn't be too hard this time because we're just going to do one line, and that is going to be a print statement, which in Python, you do print, and then you open and close parentheses. And can anyone guess what we're going to write? Within two quotes, write hello world. That's not how you spell hello. Okay. You know, classic for script, just the print. How do you print hello world? So the kind of the pieces to break down of this to understand what's different in Python is print is a function. Inside the function, you have your arguments inside the parentheses, and our argument that it takes is a string. And strings in Python are done with this parentheses, and then anything in that is what you want to print. There's definitely strings, you know, you can get into formatting of them and say you wanted to use parentheses inside your string. That can get a little bit more nuanced, but right now, this is all you need to do to print hello world. Okay, so I'm going to exit this with a Control X, and it's going to ask me if I want to save it. And then I'm going to run it with Python and then the name of my script. And then right in the terminal, you will see the output. Okay, how did I open the file? Okay, so I did it with Nano. Yeah, you can see it now. It's hidden while I'm actually in it, which is probably why it happens very quickly. As soon as I hit enter, you can no longer see what I hit. Okay, so you can also do Vim. Some people prefer it. Some people very strongly prefer one or the other. I'm not gonna tell you which one is better. Okay, do we need to touch when using nano? So I think you might be able to do nano, and then I'm going to call it like my side too. And it's just going to open up a new file for me, just like that. So you don't technically have to create it first. I think I went that way because I didn't know which text editor you guys were going to use, and it just is going to work more universally. Okay, I'm going to leave here. And since I did not make any changes, that file did not save. So I don't, but it would have if I did something. Okay, after you've entered it, how do you save and enter? Okay, so if you're in Nano again, I have these little options here at the bottom. I don't know if your terminal is displaying them the same way mine is, but for exit, it's going to be Control X. So all these little arrows are actually control for me. So I do Control X. Maybe I'll make a little change to it actually, so you can see the whole process again. Oh, I spelled that wrong. I'm going to add a comment before the line. How about like printing hello world? So this pound symbol here tells Python not to read that line. And so you can do any like human readable stuff for your own benefit. And I'm just doing this as an example so I can change the file without actually really changing anything. So I'm hitting Control X, and then it's going to ask me if I want to save my changes before I leave. And I'm going to hit Y. And then it says file name to write. So you could change your file name if you wanted. You could save a duplicate with the slight modifications like this. And that's how you save and exit in Nano. How to do it in Vim, I'd have to look up because I have not been using Vim. So hopefully you're familiar with, because I know you use like the colon symbol and then letters that mean things, and then that's how you enter or make commands in Vim, but I am not as versed in that. Is there a way to open the text editor in Visual Studio with a shortcut? Okay, let me see about a new Visual Studio workplace so we can practice. So in Visual Studio, you should be able to do a command and then, or control and then tilde to open up the terminal. And then where are we? Okay, so I can try typing nano my side here. And it opens it up like it's in Nano. So I actually don't want to do anything here. But if I moved to my directory, it would actually like show up in the Explorer as just a file you could open. I'm not going to do that because I don't necessarily want to show you my messy directory structure right now. But you can do everything in Visual Studio Code's terminal. You can also do it just by like creating Python files that appear like this. Okay, great. So we are at 2 o'clock. So I think it's time to stop and break here. Okay, I'll just be answering questions and helping people get up to speed, and then we will actually read the text file next time. And then build the directory. So I know it may not seem like we've covered a lot, like maybe some of you might have been bored, some of you might have been struggling with technical issues, and the hope is that this is like getting the groundwork. Now we're all at the same playing field. We all know what we have to do on our machines so we can all move forward together next time. And we've actually covered like quite a bit. We created your directory, your Conda environment, your Git repository. We downloaded a text file, and we used the Python print statement, and you learned what a string data type is. So it's not trivial because these are like pretty big concepts if they're brand new to you. So again, I will see you guys in a few weeks for the creating a data dictionary. So we will then read in the text file and then read the data dictionary. Let me kind of scroll up because I really appreciate your thanks and your questions, and I don't want to miss them in the chat. So I'm going to start with Kieran's question. How do I get the script to execute from the vim command? Okay, so I think you can do, I'm like nervous to use vim, but let's try because it's going to, I'll be figuring it out with you then. So if I do vim MySci, it's going to look like this. Okay, so if I want to save and exit, so maybe I should just like make a different edit somewhere up here. I'll just add an exclamation mark at the end because I'm excited. Oh, okay, so at the bottom, you see there's this colon, and then I do W. This is to let me write. And now I can go up here and add things. Nope. Okay. Vim. Write file. This is why I chose Nano over Vim, because I would frequently have to look this up and confuse myself. So it should just be W. Enter is all I'm seeing. Okay, so it says written at the bottom. Okay, now it's letting me write. Print Vim. Okay, and then to save and exit, we are going to do, okay, so this is the part that sometimes is confusing to me, is how do I get it to know that my colon is down here instead of up here? So you have to do escape and then colon, and it's down here. And then WQ is what you're going to do to write the file and quit. And then you hit enter like that. And then executing the script that you wrote is going to be the same Python mysci.py. And we've printed our 2 lines here, Python hello world, and then using Vim. So hopefully if you use Vim, that is comfortable and fluent for you, and then you don't have to re-remember what feels like extra steps to me. Vim is great. People love Vim. I'm not trying to bash on Vim. It's not my wheelhouse. So hopefully that helped you. Okay, how can you save where you are? Is this something you do with the Git commit? So your file is saved once you've exited your text editor. It is saved like on your computer's directory, but it's not saved in your Git repository. So that's something that we did with the Git add and the Git commit, and as you suggest. If that's not quite your question, please clarify in another question to Neil. Okay, how does GitHub work with Conda? Okay, so GitHub and Conda are 2 different things that aren't always interacting with each other. So Conda is your environment. It's like where your Python is. It is all the packages that you're using. Git, on the other hand, is your file saving system in a sense. And they do communicate in a way that, so on GitHub, you might save a file that creates your Conda environment. On GitHub, you might also publish your repository in such a way that Conda can download someone else's repository into their environment and use all that code. But that's a little bit like we'll discuss that as we get closer to doing that. But at this stage, Conda and Git are not interacting with each other with anything we've done so far. Okay. And yes, this will be recorded and I'm going to post it up on YouTube. If you're watching this on YouTube right now, this might sound kind of meta, and I will email everyone out the link to that as soon as it's up. Okay, James, still wondering if the sample file didn't carry over from master to main. You get this Git status on branch main, untracked files to include what will be committed, nothing added to commit, but untracked files present, use git add. Okay, so this, we actually haven't done our git add since adding our Python script. So hopefully we haven't lost too many people from the chat. And if so, I'll just do this quickly again next time. But we want to do a git status and we want to do a git add of our script, git add mysci.py, git status again, and a git commit. You don't have to do git status every time. I'm just doing it so that we can really see what's happening each time. So we're adding Python script. Okay, so if we want to see all the files that are in Git so that we can really make sure that this has happened the way we think it is, git see all tracked files. Okay, so let's try this. Git ls tree-r main name only, so we don't get everything. And then it's going to show me that I have this text file within data and my script. So let me copy this into the chat so you can do it yourself, James, and make sure that it is displaying both our text file and the Python script. Okay. Okay, James. So if that did not work for you, let me know. In the meantime, I'm going to keep scrolling through these questions. Where does Git put these files? I'm not seeing them in my Git repository. Okay, so we have kind of a hidden .git folder, I believe. And to actually see that, to see our .git directory, we can go up, we can cd into it like this. And if you do an ls, you can see everything that's in it. So even though it doesn't show up by default because of the dot in front of it, but everything in here is what's going on behind, like under the hood. So your actual, like your versions that you've saved of each file is actually being saved here, I think, in the like commit messages, or there's the logs. I haven't navigated this too much myself. I haven't needed to get my work done, but I really want to celebrate and applaud curiosity, and we can explore it together if you want to. But this is where we can kind of find stuff. So I'm going to try this command free. Nope. Okay. So I'm looking at someone's, he must be on something else. Okay. So what we have here, hooks contains the script files that are executed before or after events like commits, pushes, etc. So this is what like Git is doing, is happening here. Objects is the object database of Git. Configuration file. References. Head is our current branch. So this, I think, is where all of your files currently are. We can try to, I think we can move into that. Nope, we can't move into it, but it contains the information. So maybe I can try to look at it this way. Okay, that's not very informative. We're just exploring together here. Okay, thanks for your question, Melanie. Okay. Okay, Kevin Clark, to add a commit, would you now git add mysci.py and then git commit? Yes, that is, I think I just went over that since you've asked this question. So thanks again, Kevin. Hopefully that answered your question. Dharmendra, you're saying like, what will be the issue if you don't have Git? If Git is not working for you and you refuse to learn it, you can follow most of this tutorial without doing the Git portion of it. The reason I am showing you Git is because ultimately we want you all to be great scientists contributing to open science and reproducible science. And Git is a version controlling system that is so integral to that. And it's also important for kind of demystifying what is happening elsewhere in Python development. So I wanted to introduce it to you in this hopefully more palatable form by doing it just bite-wise, you know, just a little bit, and we'll build up to a bigger workflow. Okay. Are there any other questions or any that I missed in the chat? Thank you all for coming so much. Wouldn't do this without you, and hopefully you can make it again. Okay, I'm going to end the recording now.